Michael Bowman here. June, you know what? I think it's June 7th, 2015. Wanted to do a quick tutorial this morning before I head out with my son on databases. The other day I did a contracting advice how-to video, which I think is really important for you newbies and maybe some of you senior guys as well. And I also want to do one because of a recent project I was on about databases. This is really important because I see this, especially in the Pacific Northwest. I see this all the time, and I just don't quite understand it. Now, E.F. Codd is the father of the relational database, and he came up with some rules, and he wrapped them in a phrase called normalization. Now, there's many levels to normalization. The most common are first normal form, second normal form, third normal form. Now, third normal form is what you as a contractor want to get to if you're doing OLTP database design. Why? Because the relational database engine itself, especially the recent engines of today, you know, Oracle, SQL Server, MySQL, I don't think Sybase is a huge player anymore, maybe they are. You know, even Access, unfortunately, right? I mean, you've got all these databases out there. There's some in-memory databases too, which are really screamers. You've got MongoDB, but that's not a relational database. All right, so what am I trying to say here? All of these engines, Microsoft, Oracle, they've spent millions of dollars building these engines to do the heavy lifting. If you design incorrectly and short circuit the ability of the engine to get stuff done, well, have you added value for your client? No. Use the tools correctly and you will be rewarded. You should be rewarded. So to do that, think about third normal form. What is third normal form? Actually, what's normalization? Normalization, my friends, is a basis. It's a process. Normalization is the basis for removing functional dependencies from your tables in order to reduce or eliminate, update, and delete anomalies in your data. That is what normalization is. Any other crap people feed you about normalization, about changing table structures, is not what it's about. It's about exactly what I just said. It is about safeguarding your data. The engine is looking for good normalized stuff so it can do its job, and I'm going to show you how right now. If you can see this, I have a table here. It's got a primary key, and it's got a column called name. This is a parent table, just for giggles. Down here we have a child table. It has a parent key and a foreign key back to this key. Okay? If I put another column here, we'll call it age. I know that doesn't make a lot of sense, but this is normalized. Okay? This is normalized. Now let's say this was an order and an order item table to make it a little bit more, right? You would not want to have all of your order items in your order table, right? Because let's say somebody changed the name on the order. Instead of changing it in one spot, if you have all of this denormalized up into here, just to change one value, and if you had, I'm not kidding you, let's say you had 500 rows here of details, and somebody wants to go change the name or the delivery date or something, phone number, or, well, that'd be customer, but you get what I'm saying. Something about the order, the header, right? If you have all this denormalized up into here, you got to go update 501 rows. I mean, that's just crazy. Actually, 500 rows. You've totally smashed all your data into 500 rows of nastiness, and now you're having to manage. That's why they built relational databases. So there's OLTP databases, online transaction processing, and there's, reporting databases. OLTP is about normalization and processing data and transaction management and auditing and rollbacks, right? All that good stuff. Reporting is reporting. You never want to run ad hoc reports on your OLTP. Why? Because this database is designed to safeguard the data, do fast inserts, fast updates, fast deletes, not go out and run crazy queries with many, many predicates and joins and pull data in from all over to let you run reports. Now you can do that, but I'm going to give you some of the drawbacks. When you add indexes to tables, your inserts and your updates slow down. Why? Because if you have alternate, you're obviously going to have an index here on your primary key. You're going to have one there for your foreign key. And if you had a ton of other columns here and you've indexed all of those, when you do an insert or an update, the engine has to go update those indexes. So things slow down a bit, right? Another thing. Now, again, I want to talk about normalization, but I want to get this in here as well. Every table you design, if you're a professional, and believe me, I just saw a project up here in Portland, Oregon, where some professionals were supposed to be designing this, and they had a huge database, 500 tables maybe, and I'm not kidding when I'm going to tell you here. Not a single, can you see this? Timestamp. Not a single timestamp column in any of the tables. Why is that important? Because if you put a timestamp column in your every table, and you should also have a create date, you should have a last modified date, and you should have last modified by, what happens is, a lot like Entity Framework, or even you if you're doing it manually, SQL Server will update that timestamp value. So let's say I create a record. SQL Server stamps that timestamp value 1. We'll just say 1. It's a big hash thing. We'll just say 1. Now, I come back tomorrow and I read that record, and I'm going to make some changes, and it's a lot of complex data, and I'm making changes. And I've got data from here, maybe a few other tables, and I'm making changes, all right? When I hit save, I'm going to send that data back to the database, and SQL Server is going to check the value of that timestamp column. Why is it going to do that? Because it's while I've had that data out and I'm updating it, someone else might come along over here and go pull it out, make a quick change, and save it back. And then now the value is no longer 1. The value is, when the update happened, SQL Server updates it. We'll say 2. Now when I go to put my data back, SQL Server's going to go, wait a minute, Michael, your timestamp value is 1. But the database says 2. Somebody changed something. Now at that point, if I design the system right, it should come back to me and say, hey, Michael, somebody changed stuff. Here's the rows that are different. What would you like to do? Would you like to merge the data? Would you like to take yours and overwrite theirs? Or would you like to keep theirs? Or would you like to cancel altogether? And would you like to log the transaction you're about to do? It should probably auto-log it anyway, but you get the point. That is the hallmark of a professional system, designed correctly to support the client, give them concurrency, optimistic locking, the whole 9 yards, create dates, last modified dates, and who did it. Now, as the users, I'm a user, I have an ID or a name, that should go back, that should be part of the last modified by. That way you can look and see who updated what, right? You can even also have an audit table. And there's even a nice little trick you can do. I'm not going to get into it today. I'm going to do another video on it. And my pen is just absolutely not working. But essentially, what you can do in your tables is, just imagine you have a row of data. As the next row comes in, the updated row, you can retire this row, move it down, do an insert, switch the keys, and basically, the only way I can explain it is, you might have a table of orders, and 5 adjustments have been made to the order. So you can have 6 rows of data, 5 historical ones and 1 active one. And every time you do an update, it pushes this row down into this group here of historical, and then the active row gets updated with the correct keys and whatnot. So you always have one row that's the true row, and these guys are your historical. So you can just query for this, or if you want to see history, you can query for this and you can see it all. It's all in the same table. It actually works. It's kind of dangerous if you don't know what you're doing, but it actually works. I've done it several places. It works great. You just have to understand it. Some people use separate tables, but it's up to you. Anyway, the real issue here, though, normalization, third normal form, getting your timestamp, create date, last modified by, in. Okay? And then I want to talk to you about index analysis. So people don't do this. And, I see all these hotshot young kids who think they know, but unfortunately don't know about index analysis. Index analysis is important. Why? In an online system, again, you could have lots of columns over here. I'm just going to say age. I'm going to do it again. I'll put name, sex, and all that stuff. All right. You might need to query and have a query based on this stuff. So you create an alternate index in SQL Server because you've looked at the reports or you've looked at screens and you see that the screens call for querying and giving the user the option to put data in for this as a predicate. So you're going to have an index for it. And you have to see, and then you have to look at the data that's in here, like sex. It's either male or female. So if you got 100,000 rows and half of them are male and half of them are female, is that index really going to help you a whole lot? It's going to help you a little bit. You understand what I'm saying? If it was 100,000 rows of unique GUIDs, that might be something, or things that are partial. I mean, that's how indexes work. They filter it down and get you to the right spot, right? Quickly. But if the data is not conducive of that, it's kind of not a win-win. So do your index analysis. Tune your queries. And that's really what I wanted to do in this, about normalization. Just mention third normal form. Oh, also one other thing. Hope I can do this. Hope my pen's not going out. That's a parent table. That's a parent table. This is an intersection table. Can you see that? Man, I got to go get some new pens. So, it's a one-to-many. It's a one-to-many, right? Child, right? Or many-to-many. It's a many-to-many for kids. I mean, this is a real-world thing. A lot of people don't know how to do this. Parent, children. You got a primary key here. You have a primary key there. You're going to have a primary key here and two foreign keys that point back. One to there and one to there. And then you can fill this up. Now it's very easy to do, an inner join and get what you want, right? And again, it's normalized, okay? Don't denormalize. Normalize for OLTP. I know there was one other thing. Oh, yes. When you're naming your columns, let's say you have a column or a table called templates. Don't name your primary key templates ID or templates PK. Just name it ID or PK. Why? Because think about this. Let me see if I can draw it. We'll say table name, right? There's the table, dot PK. So if my table is named table, I don't need to see table.table PK. I just need to see table.pk or table.age or table.name or table.sex. If this table is named foo, then I just want to see foo.primary key or .id. Now, Entity Framework is built and designed to go off of, quote, ID, close quote. And you can alias that and change it around so it will use whatever you want. But seriously, you don't need to name your primary keys the name of the table. That's the hallmark of someone who doesn't get it. Just go with PK, primary key. If this is an ID column or a GUID, PK or ID. That'll work, right? When you're doing your foreign keys, when they migrate down, right? Some people like to just not do this, but I really find this is good. Let's say this is an order table. Okay, and the foreign key down here, I'm going to name it order FK. That way when I'm in this table And this is details. I can go details. I hope you can see this. Probably not because my pens are dry. We're having a heat wave in Oregon. Yeah, there we go. So there's details, right? Dot order FK. Now I can alias that on the client. I can change that and take that out. But when I'm coding and doing whatnot, details dot order FK, I know it points back to that. I got the table name and I got the foreign key. I know what it is. Okay? These are good design patterns. So ladies and gentlemen, I hope you will consider this stuff. Please. Create date, last modified date. Oh, last modified by timestamp. And I will say one other thing. I see this too. People do not understand about dates. So my father was a IBM guy who got awards for doing all kinds of stuff. And one day when I was a kid, I asked him about dates. 45 minutes later, I knew everything there was to know about dates, including how Julius Caesar changed the calendar and Pope Gregory changed the calendar, Julian dates, the whole 9 yards, UTC, you name it. Time zones. So if you don't understand date vectors, I probably should do a special video on date vectors because a lot of people don't understand date vectors, right? You've got to understand how Windows handles dates, how it handles UTC dates, and essentially, I really need to do a video on it, but essentially, when you're putting data into the database, you're probably going to want to be putting it in UTC. On the way out, Windows can translate it, right? But it's what the date means. Well, is this, okay, when in UTC, this guy was on the West Coast, I'm on the East Coast, what does it mean? These are the things you need to understand. What do they want to see in the application? Do they want to see their local time, or do they want to see his local time? Right? Now, UTC is great, and it will help you a lot. But just understand, the question is, when it comes out and Windows converts it, do you want to see it in this local time, or did you want to see it in his local time? Sometimes it's good to have two displays. One says your local time, and the other is creator's local time. I've done a lot of systems like that too. So when they're reading the create dates, they have the option of seeing both. That way they don't have to do the conversion in their head. It's, this was his time and this is your time. And you might think, well, they should both be the same. Well, not really. Because there's a 3-hour difference from the West Coast to the East Coast. And if someone creates a record on the West Coast at 6 a.m., and you're over on the East Coast and you're looking at it, the date's going to be different. It's going to be 9 a.m. for you. So depending on what you're doing, they might need to see both, or they might just need to see it in theirs, right? So think about these things when you're doing your dates. But UTC is something you should study up on. I guess that's about it. I just wanted to say those things. There was one other thing I was going to talk about. I put it in my contracting advice video. I guess I won't get it here. This is left over from kind of the other day. But go watch the contracting advice video. It'll talk to you about dealing with managers that don't know their teams and the risks that you face. So when you go in and you're smarter than everybody else and you've got all of this understood, and you're walking, you got to remember, as a contractor, you get exposed to so much. You learn. Over the years, you learn. And when you go into a place and you see people that have been sitting there working, doing the same old thing, they don't have the exposure you have. And so when you present ideas, just because you presented an idea, you could be stepping on someone's toes and you're going to get an e-ticket ride out the door. Because there's delicate sensitivities. Go watch my video on contracting advice. It'll talk about the differences from West Coast and East Coast mentalities and entitlements. Some people, the entitlements that are out there. People just, it's crazy. But go watch it. It'll make you a better contractor, and it'll make you understand that it's really a landmine out there when you're contracting. People hire you and they say they want your top skills, and they want your advice, and they want your feedback, and the minute you give it, you've offended everybody. And you've got the best of intentions. And you've offended everybody. And you're like, well, I thought that's what you want. Don't believe what the client tells you. It's not that they want to lie to you, but misinformation comes out all the time. You have to test it. And if you don't have time to test it, if they tell you up front because they're a, supposed to be a hardcore company, Scrum, collaboration, et cetera, and you walk in really thinking that's what they want, and the manager's telling you that's what they want, so you're helping the manager, you got to test this guy too. Because if you send him some information and he goes, hey, this is great, and then he shoots it off to one of his teammates, you're doomed. You're doomed because he's going to get pissed. Hey, the new guy's giving us advice. And now this guy's going to send it back to your team lead and you're going to get kicked. Trust me on this. You've got to understand the dynamics. If you have any questions, give me an email, mbowman@verticalworks.com. Make sure you watch this video a few times. Think about all this stuff. And remember, keep your OLTP system tuned up for transactions. Keep your reporting system for reporting. Pump your data across if you have to do it live or once a day or whatever. Don't run ad hoc reports against your OLTP system. It's not a good idea, okay? If you can use a total in-memory database, that'll be great. But most of the time you're going to find SQL Server, or even out on the cloud, you're going to see cloud stuff. You got the same design issues there. You got to design correctly. The cloud is not a magic pill that solves all the headaches. There's still infrastructure under there, right? I remember on a certain cloud vendor, I stressed the database. I wanted to see how far I could stress it to failure. I was in a VM, okay? I stressed it so hard, I brought down the entire I/O bus and killed the server for everybody. And I got an email from them. And I was like, whoops. I said, well, I won't do that again. I just needed to see how far I could push it. Well, their system was pretty weak. And it brought down the whole I/O bus. So you're still facing the same things even in the cloud. Okay? So you've got to design. Anything you can do to optimize the design, do it. Do it as a professional and you'll succeed. This is Michael. Have a great week.